Your learning target is I will be able to determine the number of solutions in a system of equations by looking closely at the slope and the y-intercept in my equations. You've already had a chance to look at solving systems by graphing and understanding by looking at graphs when systems of equations have one solution, no solutions, or infinitely many solutions. But I want us today to focus on the equations and what those equations look like. So you probably are already looking at these two lines and you're thinking, I already know. This is a system that has no solutions. And if that's what you're thinking, then you're exactly right. Because these are parallel lines, and we know that parallel lines continue on forever in both directions, and they don't ever intersect. And a solution to a system of equations is the point where the lines intersect. So if the lines are parallel, then they're never going to intersect. So this is a perfect example of no solutions. But let's take a moment and look at the equations. So I'm going to write no solutions, or no solution. And I want us to actually write an equation for both of these purple lines. So let's start with the one on top. I can see right away that that line has a y-intercept of 3. So I'm going to go ahead and say y equals something times x, and then I'm going to write the plus 3 because that's my y-intercept. And now I need to calculate the slope. So if I'm looking at 2 points on my line here, let me use a different color real quick. I have a point right here, and then I have another point right here at 3, 5. I'm going to go ahead and mark points on the bottom line as well. So I've got a point at 0, 0, and then I have a point at 3, 2. So I'm going to use those points to help me calculate the slope. So if I'm looking at this top line to go from the point on the y-axis, 0, 3, to the point over here at 3, 5, I'm going to go up 2 and to the right 3. That is a slope of positive 2/3. So that equation would be y equals 2/3 x plus 3. Now let's look at the bottom line. This line actually goes through the origin. So this y-intercept is just 0. I could write plus 0, or I can just leave it off completely. So I'm going to go ahead now and write y equals, now let's calculate the slope. From the origin to the point at 3, 2, I'm going to rise 2 units and go to the right 3 units. So that has a slope of 2/3. So this equation would be y equals 2/3 x. So take a look at these two equations here. This is an example of a system of equations that has no solution because they are parallel lines. What do you notice about the equations? There are two really important key features that I notice here. Number one, both of these lines have the same slope. So that's an important feature. The other important feature is that they have different y-intercepts. One of them has a y-intercept of positive 3, and the other one has a y-intercept of 0. So when looking at the equations, if you have the same slope but different y-intercepts, that would be an example of a system of equations with no solution. Now let's look at an example with one solution. So you can already tell right away just by glancing at this graph that these two lines intersect at one point. So this would be a great example of a system of equations with one solution. But the equations that are labeled there are not in slope-intercept form, so I'm going to rewrite each of them in slope-intercept form. I could either do that by looking at the graph, or I can rearrange the equation, which we learned a couple of weeks ago. So I'm just going to rearrange the equations here and rewrite both of them in slope-intercept form. So in this first one, I know that I need to move the 2x to the other side, so I'm going to subtract 2x from both sides. Then I have negative y, or negative 1 times y, equals negative 2x minus 4. Now I'm going to divide both sides by negative 1. Since technically there is a negative 1 being multiplied by y, negative 2x divided by negative 1 is just positive 2. And negative 4 divided by negative 1 is plus 4 because the negatives cancel out. So now I have rewritten the blue equation in slope-intercept form. Now let's look at the red one. I need to move the x to the other side. Now I have negative y equals negative x or negative 1x minus 1. I don't want to have that negative being multiplied by the y, so I'm going to divide both sides by negative 1. And then I get positive y equals a negative 1x divided by a negative 1 is just positive 1x. And then negative 1 divided by negative 1 is just plus 1. So let's take a look at these two equations, which are now in slope-intercept form. What do you notice about them? Let's look at the slope and let's look at the y-intercept. Both equations have, I'm going to say unique, because unique means different, unique slopes and y-intercepts. So I know that they are not going to be parallel lines or the same line. So once again, this is an example of a system of equations that has exactly one solution. I'm not going to go through and solve it, but you can see just by looking at the graph that the solution to this equation would be the point negative 3, negative 2. Let's look at one more example. Now you see 4 different arrows here because you actually have 2 lines. And those 2 lines, one of the lines is literally on top of the other line. So it's technically the same line. So it's easy to see in the graph that this would be an example of infinitely many solutions because the lines are exactly the same. But let's write an equation. So when I write an equation, I'm going to start by looking at this larger line here. I can see that the y-intercept is negative 1. So I'm going to go ahead and write a negative 1 here. And let's see if we can figure out the slope. I believe it's going to be a negative slope because it's decreasing. So if I pick this point here and this point here, I'm going to count down 3 units. That's vertical change of negative 3. And then I'm going to count to the right 2 units. So that's horizontal change of positive 2. So it has a slope of negative 3/2 x, and then the minus 1 because the y-intercept is negative 1. Now if I write an equation for this smaller line with the bigger arrows, guess what? The equation is exactly the same. Negative 3/2 x minus 1. If you notice that you have 2 equations in slope-intercept form and they're exactly the same, then you have a system of equations with infinitely many solutions. So I'm going to go ahead and just put a little asterisk here and say that the key features are same slope and same y-intercept. These are exactly the same equations. Now, if I were to try and solve these 2 equations, solve the system of equations using substitution, which is where I would set this side equal to this side, and then try to solve for x, everything is going to cancel out, and I'm going to end up with 0 equals 0. So when I solve using substitution, everything cancels out. And so that's a good indicator that this is a system of equations that has infinitely many solutions because it's exactly the same line and exactly the same equation.